Hello, I'm Robert Borengal, and this is a presentation on the schedulability analysis of aperiodic tasks, which are dependent on a shared medium. So, what am I talking about? I'm talking about aperiodic events. Aperiodic events typically have some amount of minimum time between events and some amount of maximum execution. They also sometimes have like an average rate, but we're going to ignore that for right now. So basically we have a task, and sometimes the task is like this, and sometimes the task is like this, and sometimes it's like this. Let's remove that one a little bit more. And so we've got these two metrics, which are what is the longest amount of time it can take to execute, and what is the minimum amount of time between releases of events, right? So here it takes maybe call it 2 10 minutes, and then there's a minimum time between events is 3 10 minutes. Okay, so this particular setup is going to have events which are triggered by CAN bus messages. So the CAN bus has this kind of shared medium, right? And then we've got these different types of events which come in on the bus, right? They've got some time to transmit, right? So this top is going to be like the CAN bus, and this is going to be like actual execution. So this is the transmission of the message, and then because we are using a microcontroller which has a kind of an embedded CAN controller, this takes no actual execution time, but it will release an interrupt which triggers some amount of execution. And so then while this is executing, the embedded CAN controller can be receiving another message, and then once this one's done, then we can service it as well. And notably, these things can't overlap, and these things can't overlap, but they can overlap between, like that. Okay, so so how do we model this in a traditional event model? So let's bring those tasks back. We can either lump them or split them. We can either say that this is one type of task, and its minimum time between events is the shortest one, in which case this one, and the maximum execution time is the maximum of the execution times, so this one, right? Because if we don't choose it that way, then we could end up with some we could have misleading schedulability, right? But we want the maximum execution with the minimum time between transmissions, right? But this one, it's not exactly accurate, because what if we have a really long task, right, with a really long execution time, right, and additionally a really small task with a really small execution time, right? So then we've got this amount of time between tasks and this amount of time to execute. Well, that's obviously not schedulable, not guaranteed to be schedulable. It is. And in this case, I'm defining schedulability a little bit, perhaps a little bit differently, because I'm not going to talk about deadlines. The only thing that I care about is that CAN messages do not pile up. So we want a finite bound on the maximum delay between when a CAN message is released and when it executes. These are not drawn. Normally, this execution would start at the end of the transmission of this message, but I just drew them side by side to compare their lengths. But what I was saying was that the schedulability, what I mean here is that there's a finite measurable time between when this message is released and when this message executes, or when this message finishes executing, I should say. Okay, so with that said, if we do this lumping, right, then we end up with a problem where if it transmits every 2 seconds, but it takes 4 seconds of execution, then we can't be guaranteed that that'll execute in a finite amount of time. Okay, cool. And we will put stricter bounds on this in a minute. But for now, that's what we're going to go with. So the other option is to say that we're going to split them into a bunch of tasks, and so then if it has a longer transmission time but also a longer execution time, that's fine. But we can actually, it's almost easier to come up with a counterexample of this, because if we simply have 2 tasks, both with maybe call that 80% utilization, right? And 80%, then they will add up to more than 100% utilization, and we can't say that they're schedulable. But as you may have noticed, they both underestimate the schedulability of these tasks, because in fact, clearly these are schedulable, right? So this is where the shared medium aspect comes in. That's really what we're missing, is this kind of, yes, they act kind of like independent events, but they have this shared source of event creation. So what we're going to impose one restriction, which is that the execution time of a certain event has to be shorter than the transmission time of that event. Now, of course, this is transmission time plus arbitration and whatever things of that nature, right? But basically, the time to transmit one message has to be longer than the time to service that message. And if we do that, then it can in fact be inductively proven that we will always finish in a finite amount of time. But this is a little bit misleading, because you can kind of come up with a kind of a tough example. So let's try that. Let's say that we've got a really long task that comes in from stage left, and it has a really long execution time too, right? And then we have a bunch of short tasks. I'll just draw them as bars because they're really, really short, but they also have really short execution times, right? And so you might say, well, this could pile up, right? I mean, obviously there's this is kind of a large amount of delay here, right? But it can in fact be proven, and I do this in my paper, it can be proven that this amount of time is actually only dependent on the longest execution time and cannot grow without bound. It is in fact pretty strictly bound by the execution time of these events and execution of these events and the transmission time of the smaller events. The devil's in the details, of course, but as long as we meet that one critical condition, which is execution time is less than transmission time, less than or equal to technically, then we have a bounded amount of delay between task release and task finish. You can write a paper, and it has more details, but that is the basic summary. So, thank you for your time, and goodbye.